Hi, everybody. Welcome to Ok Zoomer, Zoom chats with creative engineers and more. I'm Aaron Lichtig, Xometry guy, former Jeopardy champion, and I'll be your host today. And I'm really lucky today to be joined by Tim Simpson. Now, Tim is the Paul Marrow Professor of Engineering, Design, and Manufacturing at Penn State University in State College, PA, which is actually my hometown. So it's wonderful to have another Penn Stater here. And he's also the director of the world's first additive manufacturing and design graduate program and co-director of the Center for Innovative Materials Processing through Direct Digital Deposition. So he does a lot in the world of additive manufacturing. He has trained over 700 industry practitioners in 3D printing and additive. And you can find him at PSU Maker Prof on Twitter. So welcome, Tim.
Great, thanks to be here, Aaron. Appreciate you having me and meeting a fellow Penn Stater or state collegian guy. Yes.
Excellent. So tell us about your role at Penn State and the kind of work you do.
Sure. So my background is mechanical engineering. I've actually been teaching here at Penn State over 20 years now. I teach in both mechanical and industrial, so more of the product design on the ME side of the house, and then processing, in particular 3D printing for the on the industrial engineering side of the house. Wear many hats, as you alluded to there. We've launched about 7 or 8 years ago Sim3D, the long title there. We had to keep adding all those D's to get 3 of them. Basically, really focusing on metal 3D printing capabilities as that was starting to take off. And then based on industry interest, the number of tours we were given, et cetera, recognized the opportunity to launch a graduate program in additive manufacturing and design. And I think we're very, very specific on the end design piece there that I think differentiates our program from many others. Anybody can buy a machine and fill it with powder and hit go, but if you don't know, how to design your parts for additive, as you guys are fully aware, then, it's not going to, bring the value that you're hoping the technology can do. So grad program is spooled up. It's online and resident. We have over 100 industry practitioners now from about 60 different companies that are taking courses, another 30 or so students in residence. And along that, and then within our Sim3D group, we've been working, probably doing $6 to $8 million a year in terms of research and development projects with, DoD sponsors. A large portion of those are Navy, NAVSEA, NAVAIR, work with America Makes a lot, but then also a lot of industry projects, is certainly aerospace, automotive, oil and gas, sort of you name it. We've been involved with one or more of them at various points since the lab was founded.
Nice. So what got you interested in additive manufacturing in the first place?
Sure. It was one of those things that I'd sort of been, always thought it was cool as an engineer and as a designer. We've been talking about 3D printing for rapid prototyping for years. And, we've sort of been teaching about 3D printing, hey, here's, material extrusion and vat photopolymerization and such. That was sort of going along at a steady pace, and it was sort of helping out with product design and development. But really then in the, 8 or 9 years ago, sort of as metal systems became more readily available, sort of this uptick in sort of general interest in both the cost of the technologies are coming down, more systems that are available. It just sort of really took off, and we were fortunate to combine. I work very closely with researchers in our laser processing division within the Applied Research Laboratory, which is a Navy-affiliated university research center, and sort of their expertise on laser processing with sort of the design and industry expertise really came together at the right time for Sim3D. And then, like a lot of companies, it's sort of been holding on this roller coaster ride of sort of the excitement that's going on, the industrialization of additive, and really doing now not only the education and training, but also the research that's really needed to get these processes, up to speed and understand everything's going on, so that as companies implement them, it is a viable solution with respect to manufacturing end use parts and goods.
Great. So where, as you look at the 3D printing industry, you've been in it for a while now, where do you think it's headed over the next, say, 3 to 5 years?
Yeah, I ask that question a lot, and certainly I ask it of others as well. It's interesting now from a research perspective. I can at least say, hey, what's my newest PhD student working on that's going to be done in 3 years from now, right? So that gives us.
Yeah.
I start to think of those increments in terms of student theses and stuff. What we're seeing. I've seen sort of three waves almost, if you will, over the last 8 or 9 years. The first was sort of, hey, are we going to get the right microstructure? Are we going to get the right properties, for a metal part as we do, made with additive versus a traditional one? Now we're getting into, fatigue and sort of the longer life cycle issues some of these parts need to be able to satisfy. Obviously, throughout this, sort of the reliability and repeatability has become an issue as well. And I think the big push now is on, certification, qualification, and really understanding what do we need to do to make this, again, to industrialize these processes. And so a lot of the systems, that have been out there for a while, we still are really, getting into the bottom of the physics and understanding exactly what's going on in these systems. And so now it's all about, sensing technology and, in situ monitoring to really help ensure the quality of the parts that are coming off. Meanwhile, industry is pushing for, bigger parts, faster parts, higher laser power, larger geometries, those sorts of things. Because again, as we start to industrialize this, how do we make the business case? So material costs need to come down, machine costs are starting to come down, and other things. And then again, end of the day, it is a lot about education and training, right? Because if you don't really know how to design for these processes, your ability to make a good business case or really leverage the design freedoms that give you really may hinder or become an obstacle for industry adoption. So we've seen a lot of cases, I'm sure you experienced that as well, if somebody just says, hey, I can't get this part any other way, 3D print an exact replica of it. Well, it wasn't designed for additive, right? So
yeah.
Overhang, support structures, all the headache that's going to add to cost and post-processing. And basically you're shooting yourself in the foot there, thinking that we can take existing geometries and just make them with additive, and all of a sudden they're going to be cheaper and better and faster. It doesn't happen without some good design thinking and some sort of reconceptualization on how do we approach design given what we can and can't do with additive now.
Yeah, design really is everything if you want to make the best possible part. We see it every day.
Absolutely. Yeah. And no, I think, and you guys, one of the things that I love about sort of what you all have done is making some of your design guides and those sorts of things readily available. I recall, we keep close track on those because, what do I teach my students, right? Well, here's a nice sort of concise book or guidance, and you were one of the first sort of non-OEMs that was providing, and sharing your expertise there that I think really helped the whole industry, and others certainly are doing that well now and becoming more readily available, but that's been a challenge. You can't just sell and buy these machines and be good to go, right? There's such a steep learning curve there. And so leveraging the expertise that, that we have in our lab, that you all have had, sharing that with the broader community to really help the whole industry grow, I think has been super helpful these past few years.
Yeah, we have a wide range of webinars, design guides, ebooks, and we have a new link on our website to the Xometry Complete Guide to 3D Printing. If you haven't checked that out, please go check that out. That's written by our internal experts, our applications engineers here at Xometry. Well, Tim,
and I'll put one other plug in for you there is your cost estimation add-in for SolidWorks. That's a go-to for in my 3D printing class this semester, right? All of a sudden with with the current situation and pandemic, we no longer could go into the lab to do our 3D printing like we used to because we had to move all our classes online. So having tools like the cost estimation tool and others that are out there to be able to access and give students at least some ability to understand sort of some of the process trade-offs with build orientations and support structures relative to cost to print, et cetera. I think that's been huge for everybody, and it's great to see all of the webinars that companies are able to produce now. and are making available to students. I think that's been a huge help for me as an educator, just having more content to draw from versus yet another boring Zoom lecture with a couple of PowerPoint slides trying to make up for a missed lab.
Yeah, additive, the space moves so quickly that being good and being a droid at finding the right resources online can really help you be a better additive engineer.
Absolutely, absolutely. And I think that's one of the key things with particularly a lot of the industry practitioners and stuff. Really, when I see them writing notes down most is sort of when I say, oh, here's a good website, or here's a good paper, or here's a good this, right? Because there's just so much information out there right now. You quickly get overwhelmed and you just Google 3D printing or Google additive manufacturing, and you're getting millions upon millions of links and whatnot. Where do you start? And so that's really, one of the things that I find, particularly in our workshops and the training and things that we do, is becoming, sort of a filtering mechanism, if you will, to at least say, okay, here's where to start. And then, based on that, there's plenty of stuff to read out there.
Yeah, so what other pieces of advice do you have for somebody who wants to learn more about additive manufacturing, wants to get into 3D printing? What should they do?
Yeah, no, that's great. I think there's certainly a lot of good online resources, that you guys and others are producing. That's certainly a great starting point. I think as well, a lot of the opportunity to learn, sort of the design workflow and some of the key tools, just understanding, well, what's, effects of layering and this and that. If you can, plastic printers, material extrusions printers now are, $300, $400, $500 for sort of a low end one. Getting that and starting to think about the workflow is huge, and really starting to think about, it becomes a great on-ramp, if you will, to then think, understand sort of how do I design for additive? What are some of the limitations? And really, what are the questions that I need to ask, right, around a new process? I think that's been one of the biggest challenges. Everybody particularly thinks that with the way that machine manufacturers tout their system, right, additive can do anything, complexity is free, as people say. There's an asterisk there, right? If you don't know what you're doing, it's going to cost you a hell of a lot. And so really, doing some of the lower cost, low risk, I think that's the other nice thing about this with students, is the ability to sort of fail rapidly, learn from the mistakes. I love also just understanding, the importance of tolerances, right? You design this and print it out, and guess what? If your hole's 1 inch and your shaft's 1 inch, the two of them just aren't going to fit together. And there becomes a lot of real good practical hands-on learning that many students don't have or have been lacking in with sort of traditional educational models the way they've been.
Yeah, well, that's great advice. Well, Tim, thank you for joining us. This has been Professor Tim Simpson of Penn State University. He runs the world's first additive manufacturing and design graduate program. If you're interested, please reach out to Tim. This has been another episode of Ok Xoomer. We'll see you again soon.